In permutation and combination, we have to prove some properties of combination, which are: number one, we have to prove NCR equals to NC n minus R, and second is NCR equals to n minus 1 CR plus n minus 1 C n minus R. Now we have to prove these two properties for combination. Now we know that combination is the arrangement in which order is not important. So we have formula for NCR equals to n factorial divided by R factorial in bracket n minus R factorial. Now with the help of this formula we will prove these two properties. So let's start with the first property, that is, let us prove NCR equals to NC n minus R. So to prove this property, first we write formula of combination, that is NCR equals to n factorial divided by R factorial in bracket n minus R factorial. Represent it as equation number 1. Now put R equals to n minus R in equation 1. What we are going to do over here, in this formula we will put R equals to n minus R. Where R is represented, we will put value of R is equals to n minus R. So let us put value of R equals to n minus R. So equation 1 will become, equation 1 implies NC. Now we have to put n R equals to n minus R. That's why R equals to n minus R equals to n factorial divided by value of R we have to put is n minus R. So n minus R factorial in bracket n minus, there is R, so we have to prove R equals to n minus R factorial. While solving this, we get n factorial divided by n minus R factorial. When we solve this bracket, we get n minus n minus minus plus R factorial. So this n minus n get cancelled. So we get finally n factorial divided by n minus R factorial into R factorial, which again we can write n factorial divided by R factorial get n minus R factorial. So the final value is n C n minus R equals to n factorial divided by R factorial in bracket n minus R factorial. Represent it as equation number 2. So from equation 1 and equation 2, the right hand side of both the equations are same. That's why we can write from equation 1 and 2 we get NCR equals to NC n minus R. So let us prove second property, NCR equals to n minus 1 CR plus n minus 1 Cn minus R. Again, to prove this property, we will use formula of combination. So, combination formula is NCR equals to n factorial divided by R factorial in bracket n minus R factorial. Now, to prove this, we will make some adjustment. So, let's do it. NCR equals to n factorial divided by R factorial in bracket n minus R factorial multiplied by 1. This 1 is our adjustment because multiplying by 1 to this value, there will be no changes in the value. That's why. Now, n factorial divided by R factorial n minus R factorial multiplied by. Now, we will convert this 1 as like this, n minus R divided by n plus R divided by n. When we solve this bracket, we get value 1. So let me solve this for you. When we solve this bracket, we have to do cross multiplication. So n into n minus R plus n into R divided by n into n square. When we solve this, we get n into n square, n into R minus nr plus nr divided by n square. When we solve this, minus nr plus nr get cancelled. Now remaining value is n square divided by n square. Value will be 1. That's why we have converted this 1 like this. That's why I have already called it as adjustment. Now we will move further. Now we will multiply with this value to this bracket. We get n factorial divided by R factorial in bracket n minus R factorial multiplied to n minus R divided by n plus again n factorial divided by R factorial in bracket n minus R factorial multiplied by R divided by n. Now we get these two separate brackets. Now we will solve these brackets. So now this n factorial can be written as n multiplied by n minus 1 factorial by the property of factorial, because in factorial the value is represented in the multiplication of reducing terms. That's why n multiplied by n minus 1 factorial divided by r factorial. Now again I am writing this n minus r factorial with the same property, n minus r into n minus r minus 1 factorial multiplied by n minus r divided by n plus. Now again we will do same over here. This n factorial can be written as n into n minus 1 factorial divided by. Now this r factorial can be written as r into r minus 1 factorial multiplied by n minus r factorial completely multiplied by r by n. So when we solve this, we get this n minus r cancelled. with this n minus 1, sorry, n minus r, and this n is cancelled with this n. So we get at the numerator n minus 1 factorial divided by r factorial in bracket n minus r minus 1 factorial plus. Now in this term, this r get cancelled with this r, and this n cancelled with this n. So we get n minus 1 factorial divided by r minus 1 factorial multiplied by n minus r factorial. Now, the place of this value, we will again represent this as our term. So n minus 1 factorial divided by r factorial in bracket n minus 1 minus r factorial. I'm just rearranging this minus r and minus 1 just because we know that as in our formula NCR equals to n factorial divided by r factorial into n minus r factorial, that is numerator term and denominator term. Both subtraction is here, so n minus r r, that's why we are writing over here. In the numerator side we have n minus 1, that's why we have rearranged this n minus 1, and at numerator side we have, sorry, denominator side we have r, so we have written only r minus r, that's why n minus 1 n minus 1 r r. So n minus 1 factorial divided by r factorial in bracket n minus 1 minus r factorial. So we can write this as n minus 1 c r. This is our first term. Now we will solve this second term, n minus 1 factorial divided by r minus 1 factorial into n minus r factorial. Again same, n minus 1 factorial in bracket n minus r factorial. Now we are rearranging these. We are going to do adjustment in this term. So we are writing, as we know that we need term n minus 1 minus n minus r, n minus. This is our adjustment because we need n minus 1 minus n minus r. So when solving this bracket we get, I'm solving here this bracket separately, n minus 1 minus n minus r is equals to, now n minus 1 minus n minus minus plus r. So n minus n cancel and plus r minus 1, that's why r minus 1. So that's why this r minus 1 we have written over here n minus 1 minus n minus r. So now similarly we can write this term as n minus 1 c n minus. So this is our proof, NCR equals to n minus 1 CR plus n minus 1 C n minus